Yo, what is going on, everyone? Uh, I am doing laundry right now, so I really should be at the office working on projects and whatnot. But laundry's going, so I thought, why not try instead figure out Unity's hinge system? Because I want to do a neural network with some like hinge um, organisms soon. So I don't know. Just bear with me here. I am not sure what is about to transpire, but let's try and figure this out. Why don't we? First things first, I need to get this set up to the right place. So this is going to be our first ball joint. No, I don't want to scale it. I want to move it up to there, right? And then let's see. Let's do I think spring joint or let's see. We're gonna do a lot of testing. So I have no idea how to use this, but we're gonna duplicate, and then I'm gonna guess that there doesn't need to be two spring joints. That's gonna be my guess. There only needs to be one spring. So I'm gonna remove that, and then on this one, let's see. Let's see. Connected body is gonna be sphere 1, right? And then let's just see what happens if we run this. Okay, so we got a little spring action going. That's a good sign. But okay, so that's probably the anchor. I think that's the anchor point right there. That's bouncing. That's not correct. So we need to set that correct. Let's see. Uh, not Y, X. Okay, so there's the point. So let's set this to be, I think -0.5 should be good, and then Y should be 0. That looks about right. And then auto configure connected. Let's turn that off. Okay, there we go. So then this should be 0.5. Now this should give us some better results with our spring because the anchor points are because this is the spring is in between these two uh, um, cubes, right? At least that's my guess. Let's hope. Okay, there we go. All right, so now there's some spring action going on. Very cool. Maybe we shouldn't set the springs to the edges and let's set it to the center of each. So then let's do this to 0, 0, 0. And then let's set this to 1. Maybe this will give us, oh, not 1, -1? -1. Whoa. Okay, I know what we have to do. So we have to set this position to 1. Oh, I guess that doesn't matter. We can set this also to 1. Let's set this to 1. And we'll also set this to 1. But this to -1. Actually, no, I like -2. It's a good enough spring distance, I think. So then in this one, we can do connected to -1. No, what is it? 0? Let's see. Negative. Or just 1. Or 0. 0? It's weird. Is it really 0? How can I see the anchor point in wireframe somehow? So I can confirm. Connect anchor 0, 0. Oh! I think that this is in the wrong position. No, it's not. No, it's definitely not. Because if this is 0.6, -0.6, this is 0.6 should be, yeah. So in the middle of that is 0, obviously. And then this one, if this is 0.7 and this is -0.7, that's so weird that it just automatically sets. Oh, okay, because it's based off of this connected body. It's the transform based off of this. Okay, that makes sense. So then, yeah, 0, 0, 0 of this connected body makes sense. So now we should be able to run this and get better results, I suspect. Cool. Even better. Now, let's see. I don't want them to go through each other. So if we enable collision, boom. Perfect. Perfect. Now, okay. Okay, this is cool. I'm digging this, and it works for both, right? Oh, yeah. Look at that yo-yo action. Yo-yo action. Oh man, dude, we're already getting some good results because they can lift each other, which is like exactly what I want. Wait, lift them. Yes. Okay. Let's switch over to this so we can have like the shadows and whatnot. You can see the actual like lifting action. Okay, this is perfect because I'm kind of loosely basing. Oh, that was cool. I'm kind of loosely basing this evolutionary simulator that I want to eventually build at some point for my channel off of Carrie KH. He built an evolution simulator some years ago. Excuse me, and it was really cool. And I kind of want to like recreate that as a starting project idea. Because if I can recreate that, then we can do some more complex stuff. So first thing I want to do is I want to they're too close. Like this spring is too strong. I want to make it less strong somehow. I want there to be able to be some slack in between the two. So we're gonna go back to this window, and then we're gonna go into here, and then let's see spring. Let's see. If we can pull up Unity, the documentation for Spring, maybe it can maybe give some shortcuts. Spring join. Okay, I have to blow my nose. Excuse me. I do not know why, but my nose has been running since yesterday. Allergies, maybe, I don't know. Weird time to get allergies. Anyways, let's pull this up. Spring join documentation. Here we go. All right. So strength of the spring is the spring property, and then damper is the amount that the spring is reduced when active. Not entirely sure what that means, but I think this is a great, probably this is a great guess as we go with the spring, the strength of the spring. So let's bring that strength down. Let's see what happens if we go to extreme of 1. What happens? Okay, so they're still like bound next to each other, but it's not as strong. So this isn't what we're looking for. I'm looking for like a spring with some slack. For now, this actually might be the best way to go about doing it when it comes time to writing the actual simulator, but for now, I want to add some slack, if not for anything, at least for learning purposes. So we're going to go back to this window, we're going to exit out, and go back to our documentation. So damper is the amount that the spring is reduced when active. That's a little ambiguous. I'm not entirely sure what that means. So we got minimum distance. Okay, so maybe the distance is what we're looking for. Looking at all these, I think it's either one of the distances, probably minimum distance, and damper. Let's first try damper because it seems easier to test. So 0.5. Let's just do 1, see what happens. Let's see what happens. 1. No. I'm not even sure what that did. I'm not even sure. Yeah, documentation, when it's too ambiguous, it's a little difficult to figure out what's going on. But, okay, so then I'm going to place my money on, so we're going to set this back to default. What was it? 0.2, there we go. Minimum distance. One more time. Let's see. Minimum distance lowers the limit of distance range over which the spring will not apply any force. Okay. So if the distance between them, I think, is 1. Let's see if we can get the grid. So yeah, it's a little over 1. Maybe, but not exactly on the grid. It might be 2. Hold on. Let me see if we can plant these on the ground. Let's do y equals 0. So yeah, the distance is 2 actually, because they cross through these tiles. The distance is 2. Actually, I'm gonna bring this down just so that we can use this for future references. Okay, so the distance between them is 2. So then if we go back into the spring, let's see, the minimum distance, let's think about this. If we set the minimum distance to 1, that means that it should be able to go to here, or it'll pull it to about this line before it stops. That's my guess. Let's see if we're right with our guess. No, they're still like super bound to each other. Okay, let's try 2. Let's just see what happens. 'Cause I don't know. Okay, so now it's set to 2. They don't move at all. But if we move it a little bit, it should pull it. Okay, I think what's going on. I think I understand. Um, when we set the minimum distance to 1, I think it worked as we expected. However, because the ball starts rolling, there's nothing to really stop its rolling momentum. I don't think there's any friction on these rigid bodies. So it just keeps on rolling until it hits. So I'm pretty sure this works as expected. Once it gets to 1, it'll stop pulling. Let's see if we can simulate that somehow. If we increase the spring, then maybe it will like hit and then recoil back. Or no, it's no recoil. Okay. Yeah, there's absolutely no friction. We probably should add some friction because this is not physically accurate. Okay. Alright, so where to go from here? Let's see. I can't get that to simulate at the moment. I guess one thing that I could do is add a fixed joint to each ball to kind of stop there, or one ball at least to stop there. Let's see. Yeah, let's just do it, man. We're waiting for laundry, so we're just gonna experiment right now. Let's go cube, and then we're gonna reset its position. I just like doing this. It's not that big of a deal, but then we're gonna go here, and then here. It has box collider, and I think this should work as expected. I think it should not be a part of that. There we go. There we go. I think that just simulated what we're looking for. Let's see how I get in here. Because it hit it and then it bounced back. Yes, yes, that worked. Because it hit it and then it bounced back, meaning that they're not like bound together. It had a little weight that made it recoil back. So there's a little space in between. And I think we can simulate this even better if we were to give this cube the same thing, but we have to make it not the same weight. Because if they're the same weight, then I'm pretty sure we'll be back to where we started. So we're going to give this one just a little smaller one. And this might simulate it a little better just so we can really... Yes, there it is. There it is. So there's a spring. And I'm pretty sure that they're not bound together. Oh shucks, it's the wrong thing. I want to be moving this one. There it is. Boom, they stopped. Look at it. There it is. There's the distance. We did it. We simulated it. We proved it. This is proof that the minimum distance, if you set the minimum distance to 1, then the spring will not activate in between the distance of 1 unit distance in between them. And you can define unit however you want using Unity, but I just like to call them units. So so long as they're in between like this, they will not. But if I go past this like so, then they'll start to protract. Okay, that's good. That's perfect. It's perfect. And then if we even increase this to 2, then it should produce some more interesting results. Yeah. Boom. Yeah, so notice we can get more space in between. before it starts to pull. Boom. Very cool. Awesome. Okay, so next thing I want to test, I just want to know for myself really, is if when you nest this object with the box collider within the object, does it work as a fixed joint? Like, do I not need to add a fixed joint? So meaning that like it's gonna calculate this within its roll. Like it's gonna, like, if we rotate this right to 90 degrees, and then when it rolls, is it going to like get stuck on this and lift it up, or is it gonna ignore it? That's what I want to know. So let's find out. It gets stuck on it. Perfect. That's awesome. That's super awesome. So that makes my life a little easier when it comes time to making the simulator. Oh man, that's really cool. Unity is so powerful. It's super powerful and awesome, and it's easy to get things like prototyped and running. Now they're still bound together with the joint. So with this, you can create some really interesting things already. If I were to add a script and make them like add like random forces to them, you can get some really interesting results. And that's the objective. The objective is that I'm going to write a script to add some forces on them, and then I'm going to add like the forces that they apply to themselves. I'm going to pass that through a neural network so they get smarter about what forces to add. Shit. Another thing that I want to do at some point is to draw the actual spring. Not on this demo, because that's going to require code, and I don't really want to jump into code for this. But draw the spring so you can kind of see what's connected. Yeah, this is interesting. I'm digging this. So next thing I want to do is I actually want to get rid of these, and I want to see. This is completely ripping off of Carrie's idea, but I want to see what happens if we add this. And okay, so a third one, where would I add the spring for this? The spring should be on the first one maybe, because this goes to 1, and then that one, I don't know. Let's just try this goes to the first one and see what happens. So let's go sphere 1, and then for sure we need to set the minimum distance to like 0, because otherwise it might not work right. And let's hit play. Let's see what happens. This is interesting. So this is interesting. So this is okay. So he does pull on this. Okay, that worked. Okay, cool. Oh crap, that's not good. I need to bring him back. Come back. There we go. So okay, so he pulls on him and he pulls on him, but their distance between these two is big. The distance between these two, there is no distance, so they're like bound to each other. However, I think the minimum distance should be 0.5 at the very least, because 0 means that they're trying to attract to the center of each other, and 0.5 would mean they're trying to attract to the edge. So let's just test that. 0.5 should stop moving. Oops. Either way, you get the point. Where was I going with this? I'm not sure where I was going with this. But this is cool. This is cool to learn. Huh. Reset. Right. So, I guess the final thing that I want to test right now is if we can get some sort of like joint from here to, let's see if we can make this joint from here to here a little more stiff, meaning uh, meaning it holds this up in its Y position. Let's see, documentation. Do you have any leads? Tolerance changes error tolerance, allows the spring to have a different rest length. What does that mean? Torque, I don't want to break it. Enable collision. Yes, pre-processing disable helps. Okay. Let's see what tolerance does. I don't know what the hell that means. If we set tolerance to 1, no, let's make it more extreme. Tolerance to 5, what happens? Nothing. Okay. That's not accurate. That is not accurate because, let's see, the spring minimum distance is 0, so they should be. Okay, so I don't know what the hell tolerance does. What was it? It was point. It was 0.2. Okay. What happens if we put the 0? Let's just find out. For our own sanity's sake. Oh, there's no 0. It has to be incredibly small. Alright. What happens? Whoop. Okay, so if it's higher, it isn't accurate, but if it's lower, it's accurate. As far as like according to the minimum distance. So hold on, let's read documentation one more time. Tolerance changes error tolerance. Error changes error tolerance. So I guess allows the spring to have different wrestling. Error. I don't know. I guess this is how I came to understand it from our test we just did. If the higher it is, the less the minimum distance counts. Maybe max distance. We haven't tried that. The lower it is, the more the minimum distance counts. Maybe max. We haven't tried max yet. Okay. So, I don't know how to. How to keep this hoisted in the air. Like, obviously, right, we can do this, right? Obviously, we can do something like this, where we get a cube, because this is a stiff joint, right? Reset it, and let's get its Z to be squished, and then let's get its Y to get squished, and then let's move it, and then let's rotate it. Wrong way. We need to rotate on the Z, right? And then we'll elongate it using X, and move it in position. Probably rotate it a bit more. Boom, boom. I think you guys are getting where I'm going with this. Maybe. I'm not even sure if I get where I'm going with this. Let's get just a proper length. Okay, now we have this that connects these two. Well, I guess we would have to add a fixed joint for this. Fixed joint. And parent this to probably this. Parent this to this, and then add the fixed joint to go to, which one is this? 1. To go to 1. Now, if this works as I should expect, this will stay hoisted. Maybe not. When this rotate, it might bring it down, but this will at least try to stay. Let's just find out. Enough guessing. Oh, and it just pops off. All right. Why did it pop off? This is sphere 2. And you have this. I could have sworn when we did that test, it stayed. Oh, because it has a rigid body. Why do you? Oh, you need a rigid body to have a fixed joint. Sorry. Right. Okay. Can we add 2 fixed joints? We can add 2 fixed joints. So then let's fix you to both of them, and then you can be unparented. And now let's find out what happens. Okay. All right. Damn it. Pause. Come back to life. Okay. I actually want you up. Let's see what happens. Right. No, completely. Now this doesn't. Okay. I think it makes sense because this probably together has like a calculated weight, and this damn ball. God damn it. And this ball probably isn't heavy enough to move them. So let's see if we can change its mass, maybe. And then try it again. Maybe it should be able to move this. Barely. It can barely move it. So we can make its mass even more. Okay, now it just makes it faster. But at least it can push it. Okay. Alright. So obviously that didn't work. If we change the mass and it's rigid body. Can it pull? Oh no, it's just harder for this to pull. Okay, this is interesting. Obviously there's a lot going on here. And I'm not sure how to arrive at the destination that I want. But this has been a fun test. I think I'm going to end it here for now. My laundry's probably done. You know what? Last thing I want to do is I want to add back those cubes. I'm getting a phone call. Actually, I'm going to end it here, guys. Thanks for watching. Peace.